Let's start once again. If AB is symmetric matrix, so suppose A is a symmetric matrix, then A inverse is also symmetric matrix. We have to prove this. If AB is symmetric matrix, A inverse is also symmetric matrix. Now, how to prove this? Let us have a look. As A is symmetric matrix, so A transpose will be equal to A. Obviously, by the definition of symmetric matrix, A transpose will be equal to A by definition of symmetric matrix. Let this be equation number 1. That A transpose is equal to A. Let it be equation number 1. Okay, and this is by definition of symmetric matrix. We have to prove that A inverse is also symmetric matrix. Okay, we have to prove that A inverse is also symmetric matrix. Now, by the property A inverse transpose is equal to A transpose inverse. Okay, A inverse transpose is equal to A transpose inverse. Okay, now this is by the property which we had already learnt in the previous lectures, and if I have not told you this in the previous lectures, then please keep in mind this particular property, that if we take inverse first and then we take transpose, it is same as taking transpose first and then taking inverse of transpose. Are you getting the point? Okay, taking inverse first and then taking transpose is equivalent to taking transpose first and then taking inverse. Okay, so keep this thing in mind. So this is from the property. Now A transpose is equal to A by equation 1. So replace this A transpose by A. So as soon as I replace A transpose by A, it becomes A inverse. Okay. Now A inverse transpose came out to be equal to A inverse. Okay, A inverse transpose came out to be equal to A inverse. That implies that A inverse is symmetric matrix. What does it imply? It implies that A inverse is symmetric matrix, because this particular property, whichever matrix satisfies this property, that its transpose is equal to the matrix itself. Okay, its transpose is equal to the matrix itself. Such a matrix is called as a symmetric matrix. So by definition, A inverse is symmetric matrix. Okay, so if A is a symmetric matrix, then A inverse is also symmetric matrix. If A is symmetric, then A inverse is also symmetric. Okay, so this is the thing. So hopefully you got this particular definition.